Hey everyone, welcome back to the networking series. In today's video, we're going to talk about DHCP, or Dynamic Host Configuration Protocol. DHCP is a system that makes connecting to a network easy by automatically assigning IP addresses to devices. Whether you're connecting your phone to the Wi-Fi or setting up a new computer, DHCP is behind the scenes making sure each device gets the right IP address. By the end of this video, you'll know how DHCP works, why it's important, and how it simplifies network management. Let's get started. First off, what exactly is DHCP? DHCP, or Dynamic Host Configuration Protocol, is a protocol that automatically assigns IP addresses and other network configuration settings like subnet mask, default gateway, and DNS servers to devices on a network. DHCP eliminates the need for manual or static IP address configuration, which saves time and reduces errors. Let's take a look at how DHCP works. When a device, let's just say a laptop, joins a network, it sends out a DHCP discover message. This message is a broadcast to all devices on the local network, essentially asking if there's a DHCP server available that can provide it an IP address. When the DHCP server receives the request, it responds with a DHCP offer message. This message includes an available IP address and other necessary network settings. The laptop then sends a DHCP request message back to the server accepting the offer. Finally, the DHCP server sends a DHCP acknowledgement to confirm the assignment, and the laptop is now ready to communicate on the network. This process is often referred to as DORA, which stands for Discover, Offer, Request, and Acknowledge. These are the 4 steps involved in the DHCP process. But where does the DHCP server get these IP addresses from? The DHCP server is configured with a pool of IP addresses, also called a DHCP scope. The scope defines the range of IP addresses that the server can assign to devices on the network. For example, if the scope is set to 192.168.1.100 to 192.168.1.200, the server will assign addresses from that range to devices as they join the network. DHCP also assigns other critical information, such as the subnet mask, which defines the size of the local network, the default gateway, which is the router that connects the local network to other networks like the internet, and the DNS servers, which are used to translate domain names into IP addresses. So why is DHCP so important? One of the main reasons is that it simplifies network management. Imagine if you had to manually assign an IP address to every device on your network. Not only would that take a lot of time, but it could also lead to errors, like assigning the same IP address to multiple devices, which would cause a lot of network issues, including conflicts. With DHCP, the process is automated. The DHCP server keeps track of which IP addresses are assigned, ensuring no 2 devices get the same address. This reduces the risk of IP address conflicts and makes it easier to add new devices to the network. Another benefit of DHCP is that it supports mobile devices. In today's world, devices like smartphones, laptops, and tablets move between networks frequently. DHCP ensures these devices can easily connect to different networks without the user having to manually configure different IP addresses each time. DHCP also includes something called a lease time. When a device receives an IP address from a DHCP server, this address is only assigned for a specific period of time. This is the lease. Once the lease expires, the device has to request a new IP address from the server. This helps to ensure that IP addresses don't remain assigned to devices that are no longer on the network, thus freeing them up for other devices to use. Let's quickly go over a few key DHCP terms that you should know. First, we have DHCP reservations. A DHCP reservation allows you to reserve a specific IP address for a particular device based on its MAC address. This is useful for devices that need to have the same IP address every time they connect, like servers or network printers. Next, there's DHCP relay. In larger networks, you might have devices that are on different subnets from the DHCP server. In these cases, a DHCP relay agent is used to forward DHCP requests between subnets, allowing devices to receive IP addresses from the DHCP server, even if they're on a different network segment. Lastly, let's talk about DHCP options. DHCP options allow you to provide additional configuration information to devices, such as the DNS server, the default gateway, or even custom options like TFTP servers for network booting. While DHCP is extremely useful, there are a few situations where you might still need to manually assign IP addresses. For example, devices like servers or network infrastructure devices often require static IP addresses, so they can always be reached at the same address. However, for most devices, DHCP is the best choice. DHCP is also evolving as networks grow. With the increased adoption of IPv6, DHCP has adapted to work with the larger address space, using something called DHCP v6 to assign IPv6 addresses in much the same way as it does with IPv4. So, to recap, DHCP is the protocol that automatically assigns IP addresses and other network settings to devices, simplifying network management. The process involves 4 steps of discover, offer, request, and acknowledge, also known as DORA. DHCP reduces the risk of IP conflicts, supports mobile devices, and makes adding new devices to a network easy. It can also handle additional settings such as DHCP reservations, relay agents, and custom DHCP options. In our next video, we'll be covering wireless networking, where we'll explore how Wi-Fi works and how to optimize your wireless network for better performance. Be sure to subscribe so you don't miss it. Thank you all so much for watching. I really do appreciate it. Don't forget to like, comment, and subscribe, and I'll see you all in the next video. Take care.